Welcome to another episode of Out of the Blank Podcast. Heystek, it's a pleasure to have you back on the show, man. We have had many conversations, and a lot of them boiled down to the alien space civilization type discussions. But how have you been, man?
Well, thanks and you. Thank you for having me again.
I got a couple of questions for you. Mostly, I've been getting interested in space again. I don't know. I have these weird moments. I don't know if it's like this for you, but you work in the field as a radio astronomer, so I figure you probably have moments where you don't want to talk about space at all, or is it all space all the time?
As I like, the more I can talk about space, the more happy I am. But I'm also happy to delve into different topics as well.
Now we've always kind of boiled it down to some alien subjects, and I'm this podcast episode is not going to be without alien subjects that we're going to be talking about because I do have a couple of questions. But when it comes to new interests in space, can I ask if you've had anything recently that you've been very, very interested in?
So recently, interesting. I've started my PhD now in the last couple of months.
Congratulations.
Oh, thank you very much. So, in a different area of science, or astronomy, I'm now delving into is called correlation. And a lot of work has been done on correlation. So with correlation, it's a basic principle, but it can become very complicated real quick, especially when you do the maths. But when you have two telescopes around the world, two or more telescopes, and they observe the exact same object the exact same time, how do you correlate those data? So how do you match data from the two telescopes so they line up and you can stitch that data together to create even a better picture of what you're observing?
Now, do they both look the same? Like if you're from two separate sides of the world, you're probably looking at maybe a little bit of a different viewpoint as where it is in the sky, but it's so far away, it's still going to look like the same picture. Same reason like the moon looks exactly the same for a lot of people as well, no matter if you're in one state compared to other side of the country.
Yes, that is it. And one thing is, each telescope is different around the world. So it's like having more than one set of eyes looking at the same object. And each telescope has its own unique pros and cons, its own unique sensitivity, your own unique resolution. So by stitching the data together, you can create some really, really interesting three-dimensional images of the object you're observing.
Now, is this just for a better glimpse of what we're looking at, what's in space that we can be able to graph and be able to maybe do some research on back home? Also, I would think a lot of the science has to be good for the general public as well too. Like if you have a lot of better photos or better 3D models of a certain thing that you're observing, you can share that to many other visitors and plenty of other people to be able to give them a more educational time if they're going to a museum or if they're in a class or something like that.
That is very, very true. So the one thing with correlation is that's how you create the image of a black hole as well. Because let me actually see if I can quickly get you one of my lecture slides. I usually explain.
It's like you're basically talking to a student when you come on here, but I always like it. You're a good teacher. If you were my teacher, I would give you a great review, and I don't review anything.
Oh yeah. So let me quickly see you if I can get that slide.
Because for everyone listening, I do have this now sudden interest in black holes, and we'll get into that probably a little bit later into this discussion. But yeah, it's you start realizing space is a lot more fascinating once you actually start kind of really diving into the subject. Like I think everyone has basic space knowledge when it comes to, and it's mostly the more interesting stuff. Like UAPs is the big discussion right now. I'll have some questions about that later, but there's so much like black holes, like it sucks up everything. Now, everyone knows that and everyone thinks it's basic knowledge. But then if you really start explaining it out there, like it, everything that goes into it, like that your eyes can't perceive, sound that you can't hear, like dog whistles, like there's certain things that our ears can't pick up on certain frequencies, but everything is just gone. Things that you didn't even know existed because you can't perceive them, but you can pick them up on technology. It just goes into this empty void where I'm like, oh my, does anybody want to shout in it? Just echo and see if it does anything.
I don't. So it says host disabled participant screen sharing.
Let me check. Oh, sorry. There you go. Now you
Oh, no
are
problem.
able to
Awesome.
see.
Thank you. So let's see if this works now.
I just got to make sure no one puts up nudie photos while I'm in the middle of a rant. That would be terrible. I can just edit all this out, hopefully, if I remember.
Okay, cool. This works now. So you can probably see my lecture slide.
The Death of Stars.
So depth of the star. So when we think about black holes and when we think about the Death Star, so I usually tell my students, let's see if I actually have that image. So it's not like the Death Star, but it's actually something all like this. It is actually something more like this.
So it collapses in on itself and explodes,
Yes.
implodes.
So when we look at our stars, so usually when a star is formed, the star is formed from a stellar nebula. So that is just dust and gas with a bit of gravitational pull, and that clumps pieces together and that forms a star. And then, depending on how much mass is collected in that nebula, a average star mass is formed or a massive star is formed. So our own sun is a average star. So when we speak about mass of a star or a system, we speak about a solar mass. So one solar mass is the mass of our own sun, and we equate it to everything from there. So when we have a star that is 1 to 3 solar masses, then that is an average size star. And then when we get a star that is 3 solar masses and above, we classify that as a massive star. So when we have an average star, at the end of its lifetime, it will shred off its outer atmosphere and surface, and what was left is the core of the star. And that core will radiate energy until it's depleted all its energy and just be a big rock floating in space, essentially. But when we have stars that's larger than 3 solar masses, then some interesting stuff happens. So what a reaction does is with our star is it's called fusion reaction that keeps the star going and generates different elements. So every star start out with hydrogen, the first atom on the periodic table. So you start first with hydrogen, you fuse one hydrogen, two other hydrogen atoms together, and then you get to the next element, helium. So an average type star can usually fuse until you get about carbon. That is element number 6 on the periodic table, or right about carbon, nitrogen. That is what you get, and then it will die out, as in this image, and we're left with a white dwarf. A white dwarf become a brown dwarf, and that's the end of its lifetime. But if we have more giant stars, what happens is at the end of its lifetime, so with those hydrogen fusion is when you fuse so it starts fusing all your hydrogen, and that will increase the temperature and pressure of the star that will counteract the gravity pulling back down on that material being formed. So when we have a giant mass star, it reaches a point when that equilibrium cannot be maintained anymore, and then the star collapses in on itself and implodes. So then all the matter of that star becomes extremely, extremely, extremely condensed, and we call that degenerate material. So while it's collapsing in on itself, the outer layers will blow itself to bits. That we call a supernova explosion. So when we have a star from between 3 and 9 solar masses, then that will become a neutron star. So it's basically a star that's the outer layers is blown off in a supernova explosion, and the rest imploded on itself and formed a really, really, really super dense object called a neutron star. A neutron, so it's called a neutron star because it's still a piece of its surface is radiating energy, and you can think about it as a lighthouse flashing around in space. And that beam of energy flashes over Earth, and we can pick that up as a neutron star. But if you have a star that is 10 solar masses or higher, then that implosion becomes even more stronger. And then all that degenerate material will be squeezed into a small point called a singularity. And that singularity is basically the black hole.
Now, when how, have we been able to estimate how long the sun's lifespan is?
Yes. So our sun has a lifetime of about 8 billion years. So we're already halfway through that already. So we have about 4.5 billion years left at the rate while it's burning through its fuel. The one thing is, the smaller a star is, the longer it will take to burn through its fuel, and as longer its lifetime will be. But the more massive a star is, the more quickly it will burn through its fuel, or fuse its fuel rather, and it will create a black hole. So Have you ever thought about it with your calculator? If you divide by zero, it gives you a error, and at school maths, you are told never to divide by zero. So when you do the math of a black hole, what actually is happening with the math is you are dividing by zero.
I'm not worried about the sun like exploding and killing all of us right now. No, I'm not worried about that at all. I don't, it's definitely not going to be in so many generations, not even generations, just many millions of years down the road. But I was just wondering if with better instruments that we have today, like certain telescopes and things, are we able to get a better, more accurate depiction than maybe the mark that we made earlier on when the date of the sun is going to expire? I'm curious because if you notice about the if it's Venus, the activity on Venus, they just had volcanic activity, I believe. I don't know if you've seen that article. So I'm just wondering if there's something that's going on that's changing things that are we're seeing like not a chain reaction, but we're seeing an event happen where other planets are being affected as well too. I mean, Venus was like a dead zone. I had when we did the podcast with Stephen Kane. I mean, that's his whole area is the Venus area, and we had these in-depth discussions about it and the volcanic activity. And I mean, there's nothing before that's ever happened in that sense when it comes to volcanic activity on Venus. So I'm curious if that's an atmospheric thing, if that's its own planet doing its own internal changes, or if that's something that's going on with our sun that's giving off some type of, I don't know if there's something that we can't pick up. I wouldn't say gamma rays, but some type of rays that we can't see, or maybe we're not noticing.
Oh, yes. So that is actually very, very interesting with it. So what happens is with our own sun, while it is fusing its fuel, the surface actually expands a little bit. So that means it is approaching first Mercury, then Venus. But what's happening in Venus is that we are seeing now is we have some volcanic activity, but we also know certain microbial life causes certain chemical reactions. And that chemical reactions releases, could be carbon dioxide as a side effect. And what we're seeing is we get these chemical traces, or I would say trace elements in Venus's atmosphere that's showing, but whoa, there's something all of a sudden that's caused a process where we can see these trace elements, and that might be a form of microbial life that's forming or have been there ever since and has now been released by a volcanic eruption.
I know when I guess as the years go on, and probably it's thousands of years, not like 1 year, but when the sun is, if it's constantly changing, I know we hear about solar flares all the time and things where technology on Earth is a little bit disrupted, but I'm wondering if there's things that are affecting closer planets to the sun that could, at some point, not saying now, but in the future, way future, that could affect its overall environmental systems. Like we see with Venus, but we see a whole giant shift, not just volcanic activity. We see things where atmosphere can change to non-inhabitable to inhabitable. I mean, this whole exploration of exoplanets, basically, if you're under the age of like 27 or 28, you're part of the exoplanet generation when they really started kind of discovering them. But I'm just curious if there's something that where we have recorded before, and I always know with better or newer technology that we get to a point where we can understand more and maybe be able to correct some things that might have been right for so long that could have are now going to be wrong because we have better technology to be able to support that that's not actually what it is. This is actually what it is. I wonder about that with planets. We have a lot of stuff. I mean, I know we knocked Pluto out of the discussion, but I just start wondering when things are going to start changing to a point where either we have the technology to make that planet habitable or something else makes it habitable for us. Because there is this exploration now. I know we're not going to want to go closer to the sun, but it's definitely a lot more, I guess, research based to understand if now a planet that was not able to have any conditions to sustain microbial life is now going to be able to start sustaining microbial life because of some type of change in the sun.
Yes, so that is sweet. So yes, you hit the nail on the head. So what will happen with our own sun as it continues to age? It will swell up and become bigger. So the first planets that will actually, at a couple of million years, will actually engulf Mercury, because that is the closest star to the sun. And then in a couple of more million years, it will eventually engulf Venus. And almost at the end of its lifetime, it will engulf the sun as well. So if we as humans don't destroy each other, the sun evidently will destroy us. So as the sun comes closer to Earth over millions of years, the temperature on Earth will rise, and that will cause the oceans to evaporate at some point. And all of that will have different influence. So either life on Earth will adapt until it's engulfed, or we will need to move to the outer solar systems to now move to Mars or the asteroid belt to continue life there.
When it comes to a progress going forward, if we do talk about like, and this is a point where now the oceans are evaporating and things of that sort, do you think that we'd be more focused on trying to preserve human life by trying to keep expanding out space technology, like even in the direction with research that we have now? Or do you think we're going to be basis? Like, I would try and put more money into the fact of trying to study planets that are closer to the sun that are going to be engulfed first, just because we're never going to be able to study those again. And I know people can bring up the argument then it won't matter because there's probably another planet that wouldn't be like that at all out there in the solar system wherever we explore. So you're just getting a bunch of information that'll eventually be useless. But I go, yes, but it is still for a recorded history. I mean, as much as we are about preserving our own lives, we're also really interested in preserving our own history as well, too, our origin story or where we come from and how we became what we are today, how we get to the positions that we are.
No, that is actually very true. So one thing is, and I know Elon Musk is advocating for it, is for the us as a human species to actually continue on. And something interesting I can also show you again while
Pull up some Bitcoin. I want to see some Bitcoin.
so this will also be quite interesting to see. So this is a normal image we imagine the sun usually to how we see the sun. So I usually, where's that slide? So I usually said we can see the sun from different planets. So the image on we see now is from the Curiosity rover, and this is how the sun will look like from Mars. And here we will see the sun from Saturn. So Carl Sagan, back with the Voyager 1 spacecraft, when Voyager 1 was flying past Saturn, he recommended that they swing around the cameras and point it towards Earth. And here we can see a pale blue dot on the left that resembles Earth, which is actually very cool. So let me go on. So I usually ask my students, do they recognize this spaceship? And then I would say it is the Starship Voyager
I'm not, all I'm seeing
from
is the
Star
sun.
Trek. Did it go on now?
No, it's still on the sun slide.
Still on the sun.
If you're
Sun. So
sharing from a different
why?
browser, you're gonna have to stop share and then share the new browser. There it is. Yep.
I can see it now. Okay, cool. So I usually ask my students is imagine we are on the Starship Voyager and we go to the sun. What we'll be able to see and what we'll be able to detect. So one thing is when we look at this image over here, this is a comparison of the Earth's size to the sun. So we have a thin layer or the thin surface of the sun we call the photosphere. So what's below the photosphere, we categorize that as the interior of the sun, and what's above the photosphere, we classify that as the atmosphere of the sun. And we classify that as the chronosphere. And something very interesting about the chronosphere, let me get that image. Where is that image? Is this image. So this is how usually how we can see the sun. But one thing interesting that we're still trying to figure out why the chromosphere of the sun, so the sun's atmosphere, as you think about it, is a lot warmer than the surface of the sun and also a lot warmer than the interior of the sun, but not by a huge amount, by a couple of million Kelvin. And we have no idea why that is. And the only theory that seems to stick now is when we have the solar wind that you can see being ejected from the sun. What's causing that solar wind is the sun has, you can think about your normal magnet with your magnetic field lines going from north to south in school that you used to draw it. The sun has exactly the same thing. So when we go to this, so this is actually the sun's magnetism that's erupting and it takes part of its surface, we call it plasma, and that follow that field line from the north to the south. And we're actually thinking while doing that, it's actually dumping material in the chromosphere or the atmosphere that is increasing its heat. And I think around about 2018 or 2019, the Parker Solar Probe was launched towards the sun that will study the sun in more detail for us to get more information on it. And at the end of the probe's lifetime, they'll actually try and dive it into the sun and see how close they can get to the sun before it burns up and see what information we can get back.
What material are they using for that probe? Like, I wonder how we have a probe, or do we even have the technology to be able to pull out accurate data without our systems being disrupted by just the heat that comes off the sun?
That is an interesting engineering problem on its own because now you have to create heat shields to protect that probe. So they've calculated if you're a certain distance away from the sun, the shielding will be appropriate that you can do your readings and get sensor data. But at the end of its lifetime, they can see and push it how close they can get it and still get information. Um, but one interesting problem about it, and people don't actually realize it until they are thinking about it. The closer you get to the sun of the probe, at some point due to the heat, all your electronic components will desolder itself from the electronic boards.
Yeah, and start falling apart right before we can even pull out data. And you don't know when that's going to happen because you can't physically watch it happen. It just, next thing you know, your camera stops working.
Yes, exactly.
That's, I mean, it's intense. I didn't know we were going to send a probe out there in the first place. I figured we'd
Yeah,
had
so
pulled out images and pulled some data from it, of course. But sending a probe to be able to monitor that, I mean, it's, if I'm not mistaken, that atmosphere and everything under it, it's because the sun is extremely volatile, right? So I just wonder when we get those solar flares and things that tend to come over here to Earth is because something broke through the atmosphere of the sun and has enough impact to just reach all the way over here.
so let me see. So I just quickly Googled it. So the Parker Solar Probe was launched in 2018.
So it's up there right now.
It's up there right now.
Well, you learn something new every day.
So it was launched the 12th of August 2018.
Was there not a headline about that? I feel like I should have saw that in the news.
There should have been a headline about it.
I mean, don't be surprised when we landed on Mars, everyone was off like worried about um but the Johnny Depp and Amber Heard trial, I believe.
Oh, yes. That was also a crazy trial.
No, yeah, but the Mars landing was a little bit more important, I feel like.
So one thing I can quickly show you, I've just Googled a image of it. So here is the trajectory of the Mars Solar Probe. So when it was launched in 2018, which is further away, and as it does its orbits around the sun, they try and get a little bit closer, a little bit closer, a little bit closer. So its closest approach would be, according to this, 19th December 2024.
Oh, it's okay. We got one more year, December 19th.
Yes.
Have they tried to look what's on the other side of the sun, like explore out the not in the direction where all the planets are lined up, but just I mean in that one. I mean, we're rotating all the time around the sun, which it might be a dumb question, but I'm just curious if they've explored all areas around the sun,
Yes,
not
they
just
do.
in our
So
particular
let's
one.
see if I can get the appropriate image. So this will probably suffice. So we track what's orbiting around the sun and what's in every direction around the sun.
Yeah.
So
How
that is
far out have we
actually,
gone though? Like I have to figure out if you're sending out probes, you head in one specific direction and then try and remember what direction that you were able to coordinate that was. But we're rotating all the time, which makes it extremely difficult to be able to tell your exact coordinates 24/7.
so the one, so we have the two spacecraft that is the furthest from us is the Voyager 1 and Voyager 2 spacecraft. I know Voyager 1 has already left our solar system and is now in, you can call it international space. And I think Voyager 2 is now around about at a boundary where it will leave our solar system.
Now, are we at the point where we're expecting to receive back these technologies, or are they just going to be decommissioned once they go to a certain point and reach the end of their life?
Just decommissioned. So Voyager 1 is now so far away that it's actually very, very hard to communicate with and to receive data back from Voyager 1. But yes, every couple of months we still receive information from Voyager 1, and at some point it will be too far away for us to receive information.
God, I would like to be the psychologist that has to examine the person that goes out into space on this journey knowing they're not going to come back, where at a certain point you're going to be in complete nothingness and you're not going to have any response. Like you'll be answering the phone every day, like Rick from The Walking Dead calling that one guy in the beginning, and then you're not hearing any answers eventually, and the next thing you know, you're just floating out into nothingness and no one knows if you're alive or dead.
Oh, yes. So NASA is actually conducting quite cool psychological experiments specifically for this reason. So, one experiment they're running are in Hawaii. So, in the mountain ranges, I think it's Mianuki Mountains of Hawaii, they've set up these domes where astronauts are supposed to live in. So, to reenact the environment on Mars, for example. And when they need to go out of the domes, they need to put on spacesuits just to simulate what is the psychological effects of long-term living with your crew in the same dome over months of times. And people can volunteer for that. And it is, I think they have a experiment for 3 months, one that's run for 6 months, and one that runs for a year. You don't have communication to the outside world. You only have communication with your mission control crew, and everything's simulated. And one thing that I actually realize is at some point, the astronauts in the dome start fighting and arguing with mission control and saying, well, these people at mission control are a bunch of idiots. So I'm not going to do what they say anymore. And what a psychologist realizes to solve that problem, you actually change your mission control crew. You actually take out that crew, get a new mission control crew in that the astronauts don't know about, and then that conflicts is solved. And then with that is your interconnections with all the other astronauts around you, because at some point you're living in close quarters for months and end. At some point you're going to cause friction with another person, and how do you solve those frictions and arguments with people around you? And there's some really interesting papers that was released on the results they got from those experiments.
Would you consider space being more of a physical toll or a mental toll? Obviously, they're both probably carry a lot of weight. I'm just curious in your mind, what do you think the worst would be? Like, I feel like it would be mental. The amount of paranoia.
I also think that will be a mental toll. So, for example, is if you, let's say we have a person on Mars, to communicate with Mars, well, when Mars is on its closest point towards Earth, communication between Earth and Mars is about 3.5 minutes to send a message to Mars, and then it take about 3.5 minutes to get a reply. So then you have a time lag that as you get further and further and further away from Earth into the solar system, so when you get about to Neptune, you're around about Neptune, it would take 9 hours to send a message to receive there, 9 hours for a message to get back. So the same as we're doing exploration. At some point, you're going to start getting that paranoia stage where uh, psychological effects will start playing a major role.
Have we and this might be a dark question, but have we experimented by asking if for any volunteers in certain areas and certain fields that might be best suited for conditions, maybe not space conditions, but similar like conditions? I would feel like if you ask someone who had been a monk for a very long time, who learned to balance out their thoughts and practice years upon years upon years upon meditation, might have a better chance than maybe someone that might have some rocket or some engineering degrees. I mean, if you just send a autopiloted craft in a direction just to see how much information they can get back for we can keep getting back, how long can we keep communicating and be able to pull out some basic info. I mean, it is sending someone out into space knowing that they're probably not going to return, but I feel like if it's informed consent, you know what I mean? Like if it's not just like, hey, we're gonna send you, we're gonna see you in like 10 years, and then you send them out there. We're actually not getting you back. But we left Domino's on the ship. So you can eat as much pizza as you want until you run out, and then you're kind of done there. But I feel like if you had informed consent with the people, then I'm sure there's plenty of people out there that either just don't have family around or something that's going to tie them to want to stay here and want to go explore and be the first person to explore. I mean, that's why astronauts go up into space. They know there's a risk when they go up there, but they also want to go to space. They want that achievement. They hopefully want to make it back too. But I know, like I said, dark question, but I think it's
Oh, yes, so that
interesting.
that is an interesting question. So I know a good example is the research base and centers in Antarctica, for example. So every year, so it's a collaboration between different countries and to man the research facility and to do research in Antarctica. But every year they swap out the crew of the research facility. And one thing is, if you apply to go to research facility or to work at that research facility, the first thing is you go through physical tests to see if you're physically up for the challenge and the conditions in Antarctica. And the second thing is, I don't know what type of tests they do, but they conduct quite extensive psychological tests to see if you can survive in those conditions. So, one, if you can survive in isolation from other people, and in two, you're in close proximity to your peers around you on the facility as well. So usually each year, um, they either go from the south point of South America, the southest point, or from the southest point here in South Africa. Then during the summer months in the southern hemisphere, you get on a vessel. So it's usually one of those sea research vessels. Then it's about a 2.5 to 3 month journey on the vessel to Antarctica. Then you are dropped off at Antarctica. Then you are there for 12 months. And then the research vessel will come and pick you up again. And then it's about a 3 month journey on a vessel back to South Africa or the southern point of South America. And I know from that, I know usually each year there's a lot of people applying for it, and they fail usually due to the psychological tests.
I would feel like it will, yeah, definitely be the psychological test. I think a lot of people will be physically able to be able to be in space for an extended period of time, but it's just that madness aspect that I don't think you can get past. There's a certain point where like it's healthy to spend time in isolation, but there's also an unhealthy amount of time spent in isolation that causes severe distress on a person's well-being. There's a social energy bar that you need to fill, whether it's just telling the neighbor to stop, cutting the trees over your lawn or something like that. You just need a certain amount of communication aspects where I figured AI would fill that gap, but I'm probably guessing that AI is not at a point to be able to cover that. I know we've talked about this in the past, but digital children going into space for us to be able to explore certain instances, it's a very smart idea. It's probably going to be a direction that we're going to be heading into. But when it comes into balancing out for a manned mission, if you have someone going to an exoplanet for the first time, knowing that you're probably not going to have communication with them and however long it takes them to get there, not hyper freeze or anything like that, but just going there to balance out their own kind of insanity, I would say a chatbot. But I think our chatbots right now are not the best examples of what we want to be using. They tend to get into a lot of arguments with simple things.
But that is true. And speaking about your previous question, that's a bit darker. So a bit of a side story is here in South Africa, we have a nuclear research facility that's doing research on nuclear medicine, nuclear power, and a few of those stuff. And a couple of years ago, two postgrad students committed suicide inside the nuclear reactor. So now with the facility, so now they have extensive psychological tests. So if you want to do research at a facility or work at a facility, you actually need to go through rigorous psychological tests to make sure that something like that won't happen again.
Did they explain why they committed suicide?
I have no idea. So there were no suicide letter or anything else, but one student committed suicide, and about 8 months later, a second postgrad student committed suicide inside the reactor.
Is that just because of the work that they do, or is it maybe something more climate wise or political wise? I feel like nuclear gets a bad rep on a lot of stuff.
It does. So I think they committed suicide probably due to personal reasons and their own personal lives. But that is actually one horrible way to commit suicide.
In a nuclear reactor?
Yes.
Wait, so they like jumped in it and it just tore them apart or something?
No, so what happens is your nuclear reactor is usually kept inside water to keep it cool. And there's usually a bridge over the reactor, and you can look down onto the reactor with the water below. Actually, if you Google videos on YouTube and you just say the startup procedure for a reactor, then you can actually see it's glowing blue due to the Chernikov radiation. So both students jumped off the bridge into the water reactor, so you can shut down the reactor with safeties. So when you actually reach the reactor itself, you can die in minutes. But if they get you out fast enough, yes, you're still alive, but then you will have a horrible death in the next couple of days because all your skin and organs stop working and start deteriorating.
Yeah, it's the Cecil Kelly incident, if you've ever heard of that.
Yes.
Yeah, that's a lot of people don't know what that one is, but what's interesting to me, and I know it's like, oh, there's nothing you could do to save the guy's life, but it was like just watching and researching like the effects of how long it takes for this person to die. I'm pretty sure his bone marrow turned to ash and all these types of things that were going on. It's a horrible story, but it's like, I mean, it's the stuff that we work with, and really, in my opinion, I'm like, you pay those people more because I don't think people understand how much they're actually going through. But the it's the exploration of science that I find fascinating, which is that we always, I mean, our curiosity needs to be clenched by something or quenched by something. And that means we're going to keep exploring, and sometimes it ends up doing a little bit of bad, and it wasn't intended, but sometimes we get good research from it as well, too. I mean, the Nuremberg trials are great examples of research that we got. And it's not saying that that's a good thing that they did, but it was just like they already did it. There's nothing we could do about it. We just take the research and, try and find new ways to explore science. The reason I've been getting into the space subject is because through my John F. Kennedy discussions and hearing a lot of his speeches, I'm more interested in his assassination, but also some of the things he was saying in some of his speeches, talking about space being the new science and that we need to start exploring space. And back then, that was not the talk. It was the fear of communism. It was everything, every political candidate had to be like, we have to stop communism now. But he was like, no, we got to start focusing on science. We got to start working on like the America from 2 decades ago doesn't recognize the America of today. And just hearing someone say that, and some of the speeches he gave on national television that are some big commemorated ones about space being like this new frontier. I mean, it headed us in a direction to where now we're exploring space, where I don't think anybody would have thought we would have came this far with the technology that we have to even be able to analyze a black hole or be able to pull sound out of it. To me, that's another thing back to the black hole discussion. I mean, when you literally say a black hole, it absorbs everything. It makes sense. You hear it and you go, okay, yeah, of course, black holes absorb everything. But if you really analyze it down to the things that we can't see, and going back to our conversation, I think we did a group podcast about, or it was me, you, and Andrea Font, where you showed the graph of the universe and you showed from the beginning where the Big Bang started and then everything that came afterwards, where there was a lot of noise in the beginning and it slowly starts to fade out. And then we start seeing these galaxies and formations start to pop up. If I'm not mistaken, a lot of the beginning kind of noise, that's UV. So,
Yes. So one thing, let me see if I can quickly.
because we can't see UV, well, we can see UV light, but bugs can't see UV light. So that's why bug zappers work really effectively. They can't really see the whole UV light that we can see. So I start
No.
wondering,
So
what can we not
let's.
perceive? And that's what we're pulling out of a black hole. There might be things that go into a black hole that are still there, but we just can't perceive them because they've hit a new frequency. And that's when we get the sound that gets pulled out of it. Scientists, and I'll play this in a minute, but scientists are able to pull out the sound from the black hole. Dude, it's so eerie, I'm telling you.
That is very interesting. So let me quickly. Yes, this is the graph I'm looking for.
If I'm wrong, correct
Uh,
me. I won't be mad.
and so let me show you this graph.
I've done a couple podcasts about science before.
Oh, yeah. So you can see this graph. We call this the electromagnetic spectrum. So when we have our radio waves on the right. So the longer range, so the longer wavelengths is on the right, and that will also be lower frequencies. And then to the left, we will have our higher frequencies and smaller wavelengths because they are inversely proportional to one another. But right here in the middle of the graph is where our visible light is. So our eyes only perceive the visible light part of the electromagnetic spectrum. Then we have UV that we can detect, and UV that causes, when we are sunbathing, that causes your skin to be irritated and burned. Then on the right, we have our infrared. That is where the majority of the heat from the sun we can feel on Earth comes from. But all objects in the universe either emit energy from certain parts of the spectrum or absorb certain energies from this spectrum. We call those spectra from object, emission spectra or absorption spectra. So when we look at different objects, our normal optical telescopes is designed to look at our visible part of the spectra and a bit of the infrared. And radio telescopes, depending on what you want to observe, are designed to look at the rest of the spectrum. So now when we keep that in mind and we go to a, let's say, black hole image. So when we go to the first image of a black hole, so right now we see this bright stuff around the black hole, and inside here is the center. But this is black part in the center isn't actually the black hole itself. So the black hole is even smaller inside of the circle. So this inner circle we see is called the event horizon. So with the event horizon is, you can basically think of it as the point of no return. So if you are outside of the event horizon, then you can still have enough speed to escape the gravitational pull of the black hole. But if you cross over that boundary, the event horizon, then nothing can escape the pull of the black hole, and not even light can escape it. So that is why we see nothing from inside the event horizon, and that leaves us with a quite interesting conundrum: is how can we study what's inside a black hole if we can't even see what's going on inside a black hole?
Now,
So that is where our
is the possible theory, well, is the idea I'm guessing now is the fact that when something enters a black hole, its atoms and everything spread like very, very far apart to a point where it just becomes you don't see it. It's just whether the thing disintegrates or
It
not.
could
It
be.
just, yeah.
So we don't know. So our understanding of physics breaks down inside the event horizon. So the way we can study black holes currently is we can see what's falling into the black hole. So what is on the boundary of the event horizon. And what's interesting is doesn't matter which matter you are, as you get closer to the event horizon, it starts speeding up and those particles start rubbing against each other, causing friction and causing more heat. And if you irritate a particle enough in that way, it will start emitting X-rays. So the brighter the color is, the brighter the X-rays is that's around the black hole. And that's how we can image the black hole. So we are imaging the X-rays being released from around the event horizon. And now we are trying to determine about what is happening inside the event horizon. So what natural phenomena is happening? There's a lot of theories, but it's difficult to understand because we have no direct way of measuring or seeing inside the event horizon.
Has there been any possibilities or any ideas of a way to be able to get information out of a black hole? Like any theoretical stuff, or I have to feel like they had to send a chicken at some point, be like, "Just toss that in there, see what, see what happens." It's always they toss like a dog or a guinea pig or something in there. Don't toss a guinea pig because they're
Oh,
cute,
yeah.
but like a chicken or something. And to
So
eat it
that
anyway.
is, yes, so that is a interesting question and a more difficult question. So ideally, we want to have some sort of measurement device close enough and a measurement device that can enter. But problem is, um, our communication travels as part of electromagnetic spectrum, so they travel to the same speed of light. And if no light can escape it, then we cannot get communication with the device back because that also cannot escape it. And that is where a bit of the sci-fi comes in. You think about Star Trek or Star Wars when they speak about subspace, where you have some sort of a space outside or below the space we know that we can use to send communication through. And that is also a interesting point on its own. So that is a nice science fiction, but we need people working on it to see how we can get information out of a black hole.
Is it possible that a black hole might not be as valuable as we might think because we haven't been able to pull all the research out yet? Like I feel like at some point, if not maybe years down the road, if we don't have the technology to be able to decipher or pull out research from a black hole, we would just use it as like a trash compactor type deal. I mean, it disappears everything. We could just be able to eliminate a lot of waste. I mean, I hate to say it like that, but I feel like that would just be eventually the goal of it if you can't use it with anything.
Yes. So currently, what people generally miss about a black hole is if you think about our own galaxy, our sun is rotating around the center of our own galaxy, the same way planets is orbiting, so Earth is orbiting around the sun. So what's keeping the galaxy together and actually causing everything to rotate around the galaxy is the black hole in the center.
Yes.
And without a black hole, the galaxy won't exist and won't be knit together, and nothing will orbit one another, and no material will be kept together. So without the black hole, indirectly, we won't exist.
Yeah, but we have no way of I feel like anything that we put into it or put out of it, it's not going to do anything to it because the thing is just it looks like it absorbs every single thing. I mean, how it's a danger of testing it. Like if you just wanted to launch a nuke at it and see if, that does anything to it, like one of the biggest and baddest, and I'm sure there's been ideas about that before, but there's no way that we know that that's going to have any impact or do anything. But are you saying that there could be reparable damage if it does have some site of impact?
It could be so. One thing is, as matter falls into a black hole, the black hole will eventually grow and become bigger as it snacks on stuff that falls in. And we know we can measure two black holes that's basically collided and is forming one bigger black hole. We know that exists because we can pick that up in forms of gravitational waves. But what happens inside a black hole or at the end of a black hole, we don't know. So there's a few theories about it. One theory is that what enters a black hole exits in a different universe somewhere. But currently, we have no way to prove it, no way to measure it. And then the other part comes in if you have a black hole, then in mathematical principle, you should get the opposite of it, and that is called a white hole. And another word for white hole is a wormhole. That in sci-fi movies we can go into one part and exit in a different part of space. But right now, currently, we haven't been able to detect a white hole or see a black hole. So in theory, it should exist, but currently to now, we haven't been able to observe one.
I know out of all the things that we can't prove or we can't really dive into because of the information is not there. But when it comes to, I still find it interesting, but when it comes to ideas of things that we can really start talking about doing, I mean, when colliding, like two black holes colliding and creating one supermassive or a bigger black hole, did anybody really like when we talked about the UV in the beginning when the universe was created? And then like there's a lot of things that make up the universe and make up everything, and that's dark matter as well too. So when we talk about that, can we talk about like is that faded UV light as well too? Things that we were able to pick up, but now has hit a frequency where it's so dull that our senses cannot pick it up anymore? Is that possible?
It could be so if you think about or when the Big Bang happened and everything happened. So we call it a cosmic microwave background. And that is what we can observe around us. So in the old analog TV, when you're flipping between your different TV channels, you would see that snowflake effect. And also older analog radios, when you hear that sound between the different stations, that is roughly at 221 megahertz if you measure it. So it's part of the radio spectrum. But that is what's left behind the Big Bang for that happened that we can still pick up and still monitor. It doesn't matter where you look in the universe around us, you will always get that sound. But if you go back to the Big Bang, that intensity was it was much more intense. But as it spread out and the universe expanded, we can think about it as the Doppler effect. So if you have a siren going of a car going past, like so it became distorted. And where we are now, it's left in the radio part of the spectrum that we can still pick up, but it was more intense when the Big Bang happened.
Now, sound, how does sound carry? Is that through gravity or is that through, I it might sound like a dumb question.
That's not a dumb question at all. That's actually quite an interesting question and also a fun question. So, for sound to carry, you need matter for sound to carry through. So, if you ever look at sci-fi movies and nice Star Wars movies, and you have your X-wing coming in and hear all those nice laser sounds in space, that can't happen because space is essentially a vacuum.
In space, no one can hear you scream.
Yes, so there's no matter for sound waves to propagate through. So that's actually said in space, no one can hear you scream because you can scream, but there's literally no matter for their sound waves to propagate through. But on Earth, we have the atmosphere, we have our ground, we have a building, and all sorts of matter that sound waves can propagate through for us to hear it. So when we are hearing objects from space, that is quite interesting. So we know the sound it makes should be at a certain frequency, but there's no way in space that can propagate through, so no way to hear it. So then we reenact it and say, okay, we know what frequency that should be. Let's use our normal Earth's atmosphere as a propagation method. Then you add that into your equation, and then you can generate how it should sound like.
Now, a black hole, if it's in the center of our universe, have you ever thought about it being like a whirlpool? Like when you're in a whirlpool, when you're on the edges, it's not much force being pulled on you, but once you get in towards more of the center, it starts to feel a lot heavier and it's more noticeable. Is that kind of like that with sound? And the reason why we can't really hear things in space as well, too, is that slowly there's a lot of things that are being pulled in that we might not be able to notice ourselves, but it is just around in the area that this black hole is able to still pull slower and slower into it.
So not really. So how we perceive sound in space is not how we perceive it here on Earth. So we know how it theoretically should sound like by measuring its waves. There's no way to propagate it through anything. But here on Earth, we can simulate matter for which can propagate, and then we can get the sound of it. But one thing is with a black hole, most of the things orbiting a black hole are actually in a stable orbit. So it's not like a whirlpool sucking in. So usually in general, if you're outside the event horizon, then you're stable. Then you can orbit the black hole as much as you want without the influence. But as soon as you cross over that event horizon or that path, then it's like a wormhole or a whirlpool sucking you in closer and closer and closer to the singularity.
Has anyone had an idea of throwing antimatter or those little things? Like I always see people with videos, it gets like heavier and heavier and heavier if you just change like a certain thing in the air. I don't know if you've seen those before. It's like a
I
little
haven't seen
black,
those.
it's a little black ball, something like that. I don't know what exactly it's called. If it's, I don't know the name, technical name for it, but I was wondering something like that that changes, like if you just change oxygen or if you change something or you add something to it, it weighs from like nothing to weighing like 1,000 pounds. Like it can break through a table. It gets so heavy. So I'm wondering if you toss something like that, put something like that in a black hole, would that have any impact? It might be that's a dumb question, but I'm just curious. I'm thinking right now. I'm just thinking what we could toss into it.
Yeah. I'm not too sure about it, but in theory, yes, it should have some form of influence.
Is there anything out there that we've been able to identify so far that would have maybe a possible effect besides like something like a nuclear type situation, any types of elements, or is there still elements that we're trying to create?
So one thing is with a black hole when we want to have a something that's really influencing a black hole is you have to toss in something with extreme mass. So what we can currently measuring around the world is if we have two black holes, a big one and a small one, and a bigger one is actually feasting on a smaller one and pulling it into it, that causes gravitational waves that we can pick up from Earth. Or when it's engulfing a giant star, we can actually see that as well and pick that up. But what's happening inside, we cannot see. And speaking about elements being discovered, something truly interesting about that is that's usually where people is quite stunned when I show them this. Where is that? Yes, this is what I'm looking for. So if I show you this is just a normal periodic table of elements. So here we can see when certain stars are measured. So when we look at our heavier elements, such as gold, silver, copper, nickel, uranium, that's elements that's not natural to Earth. So when we have gold reefs somewhere that's being mined, gold is not naturally a natural occurring element on Earth. So gold is actually formed when a star goes supernova and blows itself to bits. And that supernova explosion causes a fusion reaction where you can create heavier elements. So that's why we call them rare metals, because they're not naturally occurring on Earth. So even if you think about as we speak now, yeah, we have calcium in our bones, iron in our blood. The calcium in our bones and iron in our blood is formed in supernova explosions. So it's somewhere in the universe history. There was a supernova explosion that created the elements that we are created of right now and that we can find here on Earth.
That's why people say we're made up of stars.
Yes, exactly.
Now, it's gonna. You ever heard of the element 115?
115,
I don't know if
no.
it's on the
So let me,
periodic table, but if you know about Bob Lazar and his work about Area 51 and those vehicles and stuff, there was that Russian element that was created called element 115, and I'm blanking on the name of what that element is.
so I quickly Googled it. So element 115 is Moscovian.
Oh yeah. So they say that some of the stuff that they found on, like, if you believe the alien technology discussion, they say that that's some of the material and what they labeled it as. They said that it was like a thing that you could literally put pressure onto, you could dent it up and it would just form right back into its original shape. Where I'm wondering if that, I don't know. I mean, if you believe the whole alien, I feel like if the government's talking about it, I don't, like I said, I think it's a front. I don't know if they're just trying to get funding for more research and be able to put more technology. But I mean, quest or quench the people's curiosity for exploring and wanting to talk about UAPs, because there's a lot of that discussion that needs to be had right now. But if there is true that there did found an element like that and they did name it that, I wonder if that's something that could have some type of properties that we could be able to examine to see if it would be able to survive. And I know we don't have much of that material though. I think as far as we know, I think we only have like a truck's worth.
So if I Google yes, so it could be. I'm not saying aliens exist or don't exist, but I'm open-minded. But Moscovian is one of those elements that is created in labs. One of the heavy elements that is synthesized to be created. So according to this article, it was first synthesized in 2003 by a team of Russian scientists and then replicated by a team of American scientists at the Joint Institute for Nuclear Research. But depending on what's happening in Area 51, so if they're saying it's true, it could be that I could found Moscovian on alien technology that they replicated to see how they can be created here on Earth. Um, so that is some interesting thing to think about. So I'm not saying it's true or not true, but it could be.
I believe it's probably like, if we were going to talk about the aliens thing, I think it would be government tech. I think there's a lot that went on with like that CCP balloon that happened, and I don't think that was them actually spying on us, because it's not 1983. They have better technology to be able to get information from us if they wanted it. But it is a whole area of foreign, domestic, and other spying tactics that went on that I learned through the Cold War that I believe are still happening today. Technology, everyone's always trying to steal something off of somebody, whether it's information or just figure out what the other person's doing. And I feel like if you're trying to look at a lot of these things that are in the sky, it could be some pretty new technology out there as well, too. I feel like we always are exploring in that area. It just brings in a weird conversation, like when NASA. I mean, do you believe a lot of the stuff like NASA starts talking about when it comes to director? I forgot his name's Bill something. Oh God, I'm blanking on it.
Is that the administrator of NASA?
Yeah, Bill
Uh,
something. Whatever his name is, but when he comes on air and tells people that we're looking for these
Bill
unidentified.
Nelson.
Yeah, Bill Nelson. He comes on air and says that we're gonna look for our origins on Venus, and he's saying a bunch of stuff where I'm like, what? For the longest time, you guys never acknowledged this, and now you guys are saying this type of stuff as your first memo, and now we're having congressional hearings about it, and I don't believe it is aliens. I'm just saying I believe it would be more government tech, but it really distorts like the public's interest. Where I start going, are you trying to ramp up interest into space so you get more funding? Because I feel like the best way, and I think you're headed in this direction as well, which is the public education route, which is it's way more important just to interest people in the idea of space, talking about things like black holes and really explaining it to them, because they really don't get a good job of hearing it from, unless they go to college for it or they take a private their own time to go do so. In my education system, they did not focus on space in the interest of where they probably should have focused it on. They taught you the elements, they taught you about the sun and the planets, but then you get moved on to another course. It's not properly taught in education systems, and I don't know how much time would be the proper amount of time to be displayed for that.
So what scientists now try and do is public outreach because all scientists are extremely excited if someone asks them what research they are doing and what they're working on. So it just helps people get involved because no, not a lot of people read scientific articles. And that brings me to another point I have issued last month with. So I'm actually now busy publishing a new paper on my research. And what usually happens with research papers is if you're part of a research institute, then it's nice. They just pay a subscription to the journal and you get access to all that journal's articles that have been published. But if you subscribe to a lot of journals, that subscription amount can become quite expensive really fast. So then I tried to look at, but what will happen if I make my paper public accessible to everyone? To make it publicly accessible to everyone, me as the author has to pay $2,400 to make it publicly accessible.
Yeah, it's not easy. I come across that all the time when I'm trying to read an article and says you have to pay to be able to read the rest of this. And I'm like, you know how many people are just going to tune out now? Most people will pay like $2 or $5 a month. That's fine. But eventually, especially if it's their first impression on something and it's scientific or if it's anything that you have to have exclusive access to, which if you're not on ResearchGate and all these other sites, there are free articles on there, but there's also a lot of pay ones. And people are not going to care about the information that much if it's their first time getting interested into it, which is why it's a great public service that you talk to me on my show and answer some of my questions, but also just do speaking engagements in general. But as a person that's trying to sustain themselves, I mean, if you're going to pay 2000 something dollars to be able to publish an article for free, make it public access, which is a great thing. But where do you get your money for that? I mean, can you go from institutions being able to help out and pull funding from it, or does that mess with the research that you did?
So yes, it depends on what funds you have available in your research grant. So if you're in your research grant, you have funds available that you can make it publicly accessible, then great, then we try to do it. But sometimes our research budgets are sometimes shoestring budgets, and you don't actually have the luxury to make it accessible to everyone. And then you have to work with the cards you are dealt with.
Now, do you have a WordPress blog where you can make it accessible for people to be able to be located to your blog?
Yes, so that's something that's the next step I'm working on a site that will be publicly accessible for my research. But Judy, 90% of all scientists, if you get their email address and you literally send them an email and ask, well, I've seen you've written this article, it's published in this journal. How can I get access to it? I'm guaranteed that scientist will email you the paper back.
So is it when you speak to these journals and you have money for your research grant, like are you working off a shoestring budget to where you can't afford, so they're asking you personally to take the 2000 something dollars out of your.
Yes, sometimes that happens.
Now, is there any journals that you're able to not subscribe to, but able to reach out to that do offer open public access, or are they limiting you on being able to go to certain journals only?
It depends on what your research are in. So we usually at the journal, we try to have if you publish your work, you try to have the biggest impact. So each journal has a impact factor. So the larger the impact factor, it means the more people you will reach. And if you publish your work in a journal with high impact factor, that means your work is extremely well done and you have the backing of the journal on your work. So when the problem is with your open access journals, they usually have a very low impact factor.
I understand that with exclusivity, and also it's kind of like getting a documentary on HBO. You can put it on YouTube, but you'll get more publicity if you get it on HBO. But if you upload your article to various open public platform sources, it might be harder to be able to get analytics to see how many people viewed your stuff. You'd have to check every site and then add up the total. But it would also be able to pop up more in a search function. Instead of looking at like the top article being ResearchGate, you would be on a bunch of other open public source academic journal articles or sites that I do visit very frequently.
Yeah, that happens. And then on the other side is usually between governments and research institutes, they are usually subsided. So when you publish in a certain journal, the government subsides so you get back in research funds for the work you have done.
Okay, now I'm seeing. So basically, if you put the money out, you're banking on the fact that if it does get picked up, you get the money back.
Yes.
Huh. That kind of sucks as a researcher, though, because then it's like, how do you try and be able to want to have the motivation to create new research if you're limited in such a way?
Yes, that's exactly the problem we as scientists have around the world.
Now, is this come down to just not a lot of funding or a lot of public interest in a lot of certain areas in science and space? I feel like it is like pretty popular. Space obviously is. There's plenty of magazines that are dedicated to that. But just general public curiosity. I mean, you got people that worried about bills, going to their jobs, daily life stuff, where their main interest is like CNN and Fox. So, like, you'd have to get publicity on one of those networks. Like, if they said a meteor was coming to the Earth, then a bunch of people would get interested into it. So, when it comes to your mission and your research article, what is your direction that you're heading in?
So for me is for my research article, I just want to get it out there. So with me is with the university I'm forced to use or one of the journals they are subscribed to, because how it works is if I publish in that journal, then from the university you get $2,000 back for each person that publicizes in a article that helps with your own research funding.
So, have you tried to GoFundMe? Have you tried to do anything to be able to help pay some of your way to be able to put one of those articles in there and hopefully get the money back?
That's one way you can do it, but again, it's all what you have decided beforehand with your research institute.
Now, what is your research about?
So the research publicizing about is I've developed a new way for radio telescopes where you can, so usually when you observe an object, you have different, I would say, end piece of technology you can hook up to it. So whatever do your observation or do your recording. So the one thing is we call it a spectrometer that creates a spectrum of the object you're observing, so to see what radiation it emits or absorbs. And from that, we can determine its composition. Or we can have a radiometer that determines the total power and temperature of an object. So what I've done for my research is I've developed a new way where you can do radiometry and spectroscopy on the exact same time and exact telescope. So instead of doing an observation using your spectrometer, then redoing your observation using a radiometer, you can do both of them at the exact same time on the exact same device, or back end as we call it. And then also my spectrometer, I have developed a way so when you look at your spectrum that's created from the object, that you can pick a piece of that spectrum and zoom into it and get more details on it.
So is it cutting a lot of stuff in half? I don't, what's the issue with it? Is it just because it would take more money to be able to redo the process, or is it a whole new learning curve?
Just a process to, it's a new learning curve as well, but also to redo the process. And then with that, there's also your intellectual property that you're working with. So how it works usually across the globe is if you're affiliated with a research institute, then they own your intellectual property. But the only to the fact is because you're using their resources to do development or discover something new. But also on the same hand, is say, for example, you've developed something that is quite dangerous. For example, say you are a chemist and you have discovered or developed a new kind of poison or a new biological weapon, for example, then you have the legal department of that research institute behind you, protecting you in that way that doesn't fall in the wrong hands, and make sure it's appropriate governance around it.
I'm getting it. I'm just wondering what's the issue with radio telescopes? Is it just, is there a lack of interest in the radio telescope field? I feel like there should be a
So
particular
yes,
interest.
so there's a bit of lack of interest. So if you think about, so we usually joke and say the astronomy community is a very small, tight knit community. So we try to get more people into astronomy, but then especially when you have different governments trying to get funding in research grants. The problem is with your different research grants is um, governments see different places where they can rather use the money. So they can rather use the money to provide housing for the poor or improve the healthcare system. And therefore, research grants are usually limited. So I know we are only now after the COVID pandemic recovering because during the COVID pandemic, all our research funds and grants were basically halved because the government decided they're going to rather use the funds to help better the healthcare system and prepare for COVID. And now, post COVID, we are only now getting our normal research funding back.
I mean, I hate to be the guy that says if they've been taking half your money and putting it into their, ideas of implementing ways to help, they did a shit job of it. I mean, we still got a huge homeless population issue, and we still got a lot of Medicare and healthcare issues as well too. But God willing, it's going, I guess, apparently to
Yeah.
the best place. Uh, yeah, that's a difficult situation. There's an area I've been getting interested into, which is academic influenced research, and to look at all the crippling things that, certain people are researching into, where they come across unethical situations that they get put into, research integrity. Like, I mean, it's the same thing with journalism as well, too. Some stories don't get reported because there might be a conflict of interest on the basis of who might be friends with this certain. If you have any links or anything I can put into any of your episode descriptions, I should be able to help get you anything. If you got a GoFundMe or anything, WordPress, anyway. I mean, you're getting the word out now. Is there any links that you have that people would be able to find to be able to help support you to be able to get your research published in a open public article?
So as soon as I've published my article, then I will send links to it wherever it's published, and the more people can view it, then the better it is.
Yeah. I mean, even if you publish it on one that you don't have to pay money to, if it's just a smaller, lower one, and you publish it to a bunch of them, I can link all those links in so people be able to find it as well
Perfect.
too.
I'll send that to you.
And is there any other links you'd like to promote, Heystek? I mean, you've given me enough of your time today.
So if people want to interact with me or find me, they can reach me on Facebook, Twitter, and Instagram and LinkedIn. Facebook and Twitter, you can get my surname, Heystek Grobler, and Instagram and Twitter, you can get me the handle at Heystek Grobler.
And I'll make sure I link all those in the description. It's always a pleasure chatting with you, man.
Thank you. Nice chatting to you, Robbie.
And thanks everybody for listening to this episode of Out of the Blank Podcast.